Okay, so we're now on the next question where it's asking about the real molecules. So we're going to actually see real molecules and what their shapes are. So we're going to go ahead and click on that button. Okay, and so we have real right here. And if I click model, it'll just bring it back to the other model. It doesn't really matter, but I would just keep it clicked on real. That's fine. You're going to see that you have a drop-down menu right here with all these different molecules. Now, be careful. I'm not asking about all of these molecules. So only do the ones that are actually in the table for your class. And then make sure that you have show lone pairs, because if I take that away, then we don't see the lone pairs there anymore. So we want to have that box checked. And we also want to have show bond angles checked. And you're going to see that a bond angle shows up. And sometimes you'll have multiple ones, such as something like that. No, not that one. Sorry. Like that. You can see that it shows up 3 times, but really they should be pretty similar. So there'll be a couple boxes where I'm going to ask you to please add in the bond angle that you see. So let's leave it on H2O for now. So we see that that one's 104.5. Then also click molecule geometry, and that way you're getting your different shapes of these known, well-known molecules. Okay. So for our first thing in our table, you see that we have H2O. So H2O looks like this. So you see that I've already added that image into your table. You see that it is known as bent. So that's already also in your table. I've added in the angle 104.5. Then it's asking, does it have any lone pairs? So looking here, we have 2 sets of lone pairs. So the answer is yes, which is what I put. Symmetrical. So when we're looking at whether it's symmetrical or not, you're going to have, so you've already kind of gotten some notes over this, but you're looking to see, is there the same thing all the way around it, or is it kind of unbalanced, making it a polar molecule? So remember, unbalanced or not symmetrical is going to be a polar. And when it is symmetrical and it's surrounded with the same thing all around, it's going to be nonpolar. So for this one, this is a polar molecule. Another little hint is if you see any lone pairs on your central atom, so the one that's in red, if you have lone pairs, then they're pushing down on the 2 bonds that are right here. And so that's also going to be a polar molecule. So you can kind of use that logic as well. Okay, so there is our first one that's already filled in for you. So now that you've seen that, you can either start on the simulation by yourself, or you can follow along if the simulation isn't opening for you. So the next one that we're going to look at is going to be CO2. So looking here, you want to pick the molecule that looks like this and add it into your table. Then you want to write down what the shape is, so the molecular geometry, which is linear. Then we see that the bond angle is 180, meaning it is a straight line. So when we have linear things, that's a straight line. Does it have any lone pairs? There are none on here, so no. And then finally, is it symmetrical? So looking at this, does it look balanced? Are there any lone pairs on that central atom? And the answer is no. So it is definitely balanced. So this is going to be a non-polar molecule. All right, the next one that we're looking at, we've got SO2. So I'm going to click on SO2. So what we see that we've got here is we have our sulfur right here in the center, 2 oxygens, and a little lone pair on top. Okay, so looking at this, we do notice those are double bonds, so that should help as well. But we are going to pick the one that looks like this. Then we're going to click on bent. Our degrees or our angle is 119, which is already in your table. Are there any lone pairs on a central atom? And the answer is yes. And then, is this symmetrical? No, it is not symmetrical. So therefore, this makes it a polar molecule. All right, the next one we're going to look at is BF3. So for BF3, we kind of see this going on, okay? So pick that image, put it into your table. Make sure you click trigonal planar and add that into your table. Remember, planar means that it's flat. You can kind of see that if you move this around, or if you're watching this video, you can see that it stays flat. Your angle is 120 degrees. The way to think of that is that it's 360 divided by 3 sections. Are there any lone pairs? No, there are no lone pairs on this. And is this symmetrical? And I would say, yes, this is symmetrical looking at it, and therefore we would consider this to be more of a non-polar molecule. All right, the next one that we're going to look at is NH3. So we're going to click on NH3. So a couple things to notice. Let me rearrange this one a little bit. There we go. Okay, so pick the image that looks like this. The shape that it is trigonal pyramidal, meaning it kind of stands up like a pyramid. You can kind of see that happening right here. Okay, so those little lone pairs just kind of sit on top of it. The angle that we're dealing with is 107.8, and that's already in your table. Is there a lone pair? Yes, that's already in your table as well. So since there's a lone pair on that central atom, that blue atom right there, since there's a lone pair, remember what I told you at the beginning, that would make it a polar molecule, unbalanced, not symmetrical. All right, and finally, our last one that we're going to do on this little screen is we're going to do CH4. So here's CH4. So as you can see, this is the one that had like 4 single bonds. Okay. So pick this image. It is known as a tetrahedral. The bond angle is 109.5. There are no lone pairs on this central atom. And because it is the same atom all the way around it, those are all hydrogens, that would make it non-polar. So it's symmetrical, so it is non-polar. All right, so that's it for this table. So be sure to don't exit out of this yet, because you might be needing this on your next question.